All right, good evening, everybody. Today we're going to be doing practice and problem solving for generating equivalent expressions. Before we start, I want to go over two basic concepts that we went into class that I don't want you to forget. One is commutative properties, the other is associative properties. Okay, I'm going to give you examples of each. First of all, commutative properties, I'm allowed to rearrange the order of the numbers as long as I'm adding or multiplying. So if I was to say that I have 3 plus 7, okay, let's just say these are in parentheses, and I say plus x, that will be equivalent to, let's see, if I rearrange the order of this x plus 3 plus 7. Now notice I didn't change where the parentheses was, okay? I just changed where the numbers went. The numbers are in the same order that they were in, but I changed where the numbers are located, but in the parentheses they stayed the same. Okay, so I changed the order of what is being added, okay? But it's still going to equal the same because when I'm adding, all numbers come up to the same sum. You can do this with multiplication as well. All right, and if this was, let's just say 3 plus 7 plus x, I could also just as well say that I'm going to change this to, well, 7 plus x plus 3. Okay? In this particular case down here, though, when I had the parentheses, I didn't want to change the order it was in it because then I would be dealing with associative property as well. Let's look at associative property. Associative property is taking the parentheses and moving them, but not moving the order. Okay? So let's just say I had the same example, 3 plus 7, and in parentheses, plus x. This would be equivalent to 3 plus, parentheses, 7 plus x. Everyone notice I kept the order of the numbers and variables, but I just moved the parentheses around. So associative means I'm going to move my parentheses, my groupings, and then commutative means I'm going to go ahead and move the numbers around, okay? All right, so let's go ahead and try to work these out. I'm going to do all the odd ones. You guys got the evens today. Let's see here. We've got -3. This just says writing equivalent expressions. It doesn't say that whether we have to do this using commutative properties, associative property. They just want an equivalent expression. Well, this one's pretty easy because I can use my distributive property to multiply what's in front to everything that's inside and rewrite this expression. -3 times -7 is -21. Now, -3 times +5 is -15. So -3 times +5g is -15g. All right? And that would be my new expression for step number 7. Okay? I'm going to leave number 8 for you. I'll give you a clue. You definitely want to use one of these commutative or associative properties. Over here we've got 2/9 minus 1/5 plus x. Well, this is pretty easy to find the same one because I'm subtracting and I'm multiplying. Okay? Now, this tells me I've got to take my symbols, okay, and move them around. But I can't change what I'm multiplying here, okay? So I could write this as, let's see, remember, we could write this as, well, 2, let's see, no, I'm going to try this a little different here. I could write this as negative 1/5 times x, okay, and then I could add it to 2/9. All right. Now, some of you are saying, hey, you can only do this with adding and multiplying, you said. But remember, I'm taking a negative 1/5 and I'm adding it to 2/9 because this is a positive number. So I can change the order that I'm doing addition. Okay? So I basically am taking the subtraction out of it and making it into an addition problem. That would be almost equivalent to saying, let's see, if I was to rewrite this as I was 2/9 plus -5 or negative 1/5. Okay? All right, so let's move on to number 11. Says the distance in feet that Karina swims in a race is represented by 4d minus 4, where d is the distance for each lap. What is the expression equivalent to 4d minus 4? Well, once again, we can look at this in two different ways. One, I could say this is a subtraction problem, or I could make it into and express it as an addition problem, right? Let's see, what is an expression equivalent? I could say this is 4d plus -4, and now I'm free to use my commutative property and say that this is -4 plus 4d. Does everyone see how I did that? I used addition, even though there is a subtraction sign there, to rearrange my expression, okay? And I'm allowed to do that because every number really starts with a positive or negative sign, okay? Well, I don't have to look at this as addition and subtraction. All right, let's go to number 13. Nigel is planning his training schedule for a marathon over a 4-day period. He is uncertain how many miles he will run on 2 days. One expression for the total miles he will run is 12 plus y plus 17 plus z. Use commutative properties to write an equivalent expression. Well, we're adding all across here. So I could rewrite this simply by saying, let's see, y plus 12 plus 17 plus z. I'm going to go a step further. Since I've got 12 and 17 together, oh, I'm sorry, this was z. I think I'm just going to go ahead and add my 12 and 17 together because it is also an equivalent property. I could just say that y plus 29 plus z. Heck, if I wanted to, I could even say that, let's see, y plus z plus 29. And I'm still writing an equivalent expression, okay? I'm going to go to number 15 now. Write an expression equivalent to x minus 3y plus 4. Once again, I can break this down by saying this is really x plus negative 3y plus 4. And if I wanted to rewrite this, I could simply say that, well, I'm going to claim that negative 3y plus 4 plus x. I could even say that this could be, well, uh, let's see, x plus 4 plus, or excuse me, minus, I should say, minus 3y. Now, would that be correct? Let's think about this for a second. I want to make sure that we're doing the right thing here. We do know that we're adding negative numbers here, but we have to remember when we're subtracting that we have to put these in the right order. Now, the reason I went ahead and did it this way is to make sure that we understood that we are taking these numbers and we're subtracting them from the right amounts. Now look over here. This is x minus 3y. Now notice over here, you have to be able to show that you're subtracting, okay, negative 3y from x. Look very carefully here, okay? In neither of these cases am I doing that, right? So I want to make sure that we've understood this properly, okay? You would think that you'd be able to go ahead and do all this, but I want to go ahead and show that you have to do it properly. So in this last one here, to make sure that we are only using addition, remember our community property means addition, I'm going to change this, okay? To show that I'm adding a negative 3y. Okay? Now this one could be at the beginning, all right? But at the end, because we're still adding, right? But if you're using at the end, I want you to put the parentheses around it to show that you realize using the commutative property and only adding numbers, all right? Okay, let's do number 16, or no, number 17. This is high order thinking. But before we do, let's get our secret code word in, okay? And I'm looking at a magazine, and it says the heart of a selfless child. So the girl is holding a teddy bear. So we're just going to put the secret code word. It's not actually a word today. Okay? We're going to go ahead and put this teddy bear here. Okay? And since this said the heart of a selfless child is a teddy bear, we're going to go ahead and draw a heart around the teddy bear. So if you guys draw a heart and then the face of a teddy bear, okay, I'll know that you know the secret code word, all right? So let me erase that now so nobody else sees it. And I am going to go ahead and get number 17 going here. High order thinking. To rent a car for a trip, our friends are combining their money, all right? The group chat shows the amount of money that each puts out. One expression for their total amount of money is $189 plus, or 189 plus P plus 224 plus Q. Well, let's write that out. One expression of their total amount is 189 plus P plus 224 plus Q. All right? So let's use the commutative property to write two equivalent expressions. So since I'm going to use the commutative property, that means I can rearrange the order of the numbers. So in this case, I could just write, well, one example could be 189 plus 224 plus P plus Q. Another example, I mean, all I've got to do is just pick an example where I rearrange the order of the numbers. I could put 189 plus 224 again. And this time I could make it Q plus Q plus P, all right? And that would suffice. I'm sure there's other orders you could do, like Q plus P plus 189 plus 224. A number of ways you could rearrange the order. All right, the next one says, if they need $500 to rent a car, find at least two different pair of numbers that P and Q could be. Well, let's do the math. First of all, 189 and 224. That's going to make, let's see, it's going to give me 3, carry the 1, that's 11, carry the 1. That's going to be $413. So I have to subtract 413 from 500 to see what I need. And that's going to give me, looks like $87. So I need to pick two numbers that Q and P could be that are going to equal $87. Let's see. Well, I could pick, let's see, find at least two different pair of numbers. One pair of number could be, well, I know that, let's see, 70 and 17 make 87. Let's see, I could also make, well, I could make 50 and 37. I suppose I could even make 40 and, let's see, 47. Any two numbers that are going to equal 87 could be P and Q. All right, and that's all of them that I had for tonight. Hopefully this helped you with your homework, and I'll see you in class. Have a good night.